Okay. All right. So, excuse me. All right. So that was this morning. All right. So we are in geometry that meets Mondays and Thursdays at 9. We are in term 4, which runs from April the 5th to June the 11th, 2021. I believe all of you are already enrolled, but if not, this is the enrollment code for Summit. And all right, so, uh, you know what? They told me I don't have to, no recording. All right, so again, the keys to success. So that you'll be successful in the class, come to class, be on time Mondays and Thursdays, participate in class discussions, answering questions as well as asking them. Have your materials, complete your assignments on time. If you miss the class, you have 3 options. We have afternoon labs from 1 to 3. You can watch the video of the class. Like I said, I have been posting them on the Yes Philly YouTube. I don't know if it's YouTube page, YouTube channel, but it's on there. And good morning. And you can contact your teacher through email. Okay, and again, our emails are constructed the same way yours are. So I'm Lisa Hickson, so my email address is lhickson@yesphilly.org. And your grades, 3 parts: your assignment, your attendance, and the final. You can't pass the class without all 3 parts. And so far, you all have the attendance piece together. So I thank you for coming. All right, so we're talking about circles. So our goal is for you all to be able to write and discuss the definition of diameters, radius, and chords. Oh, I lost somebody. And the standard, again, is just that guide that math teachers across the country use so that we make sure that we all are teaching our students the same content as long as we are teaching this unit. So for us today, our agenda, we just had our community meeting. It was the question about which one must go. So we're going to talk about angles and arcs of a circle, arcs and angle relationships. Then we're going to do a little practice and then a close. Okay, so hopefully we will get through it all. And again, you all are in the second half of geometry. So this is like a continuation. So I'm checking to see what you remember. All right, so we are going to talk about angles inside of a circle. So I am going to fill this slide out as we talk about this picture. So my question to you, any of you, I want you to name an angle. Now remember, we name an angle how? Anybody remember how to name an angle?
So you said name an angle.
Uh-huh.
You were talking about like the core and stuff like that.
I don't know. You tell me. Name an angle. Name an angle that you see in that circle.
Alright, so I see E. I'm talking about E. Yeah, EPC, right?
EPC. Yep, that's a show. Okay. All right. So we see EPC. Anybody else see an angle? It's more than one. And you can put it in the chat.
Can you hear me now? Because I don't think you heard me.
Yes.
Alright, I
Yes, I hear
said
you now. Wait a minute. Let me find this.
EPC.
Okay. All right. So you said angle EPC. All right. I agree.
And then I
You
said
see another one?
FC.
Wait a minute. F, go ahead. Wait a minute. You said FC. Where does it end?
You said where do it end?
Yeah, you said FC. Okay, so I don't know. What is
That's
FC?
huh?
Say it again.
Wait, that's not an angle.
Is it? Look at it. You said, I'm gonna bring it back up. You said FC. Is that an angle? I started at F. You told me to go to C. I'm there. Where do you want me to go? From C. Where am I going to form the angle? I'm sitting right here. Where am I going?
You talking? Wait, because you talking to me?
Yeah.
Oh,
You said, I said, name an angle. So you said EPC. I agree. That is an angle. It is a straight angle, but it is an angle nonetheless. And then you said FC, and I'm sitting here. I said, where am I going?
oh, no, because I figured because it was when the circle that it was and but wouldn't that be considered an angle though? FC. I'm asking.
No, FC is a what? That is a line segment that goes from one side of a circle to the other. So what is that?
So that's not an angle then. All right, so you can take that off.
But no, finish the angle. Somebody help her finish the angle.
Wait, hold on. FC.
Where we going to finish the angle? You just drew a line.
FCP. No, wait.
No, finish. Go all the way back over. Keep going. Go beyond P.
FCA.
Yes. All right. So again, there are other angles. Somebody else. All right. So yep. So FCE. Go ahead. You see any other angles? I'm gonna blow it back.
You got eight. Excuse me. APC.
Yep. From A to P to C. Yes. Okay. Good morning. A, P, C. All right. Anybody see anything else? So now we have EPC. We have a straight angle. That'll work. We have FCE. That'll work. We have APC. That'll work.
Can BPD be one?
No, go the other way. Start from D and go up.
DPD. Here we go.
DP where? Because look, think about where you're going. D to P. Now where you want to go? Which way? Where do you want to end? Because you can go a couple places.
Oh, wait, hold on. I don't even peep that.
All right, so wait, let me see. I'm going to blow it up for you. You want to start at D. You said BPD, which is yes. I will add that because that is still a straight angle. So I'm going to add that. But if you start from the bottom, DP, now where you want to go because you got options.
You could go to DPA too. My fuck, I didn't even see that.
Exactly. Right. You could go to DPA. Exactly. So ladies, and if I don't know if any gentlemen joined, but if you did, so I'll say class. The point is there are several. You said D. Wait a minute. You said DPB. Then you said GPA. Okay. So again, the point is within this circle, you have several angles, right? So you have angle EPC. So that's the diameter. It's still an angle, ladies and gentlemen. I mean, or class, because it's a straight angle. Okay? So that does count as an angle. You have angle FCE. Now, that angle, because it has the vertex, the point where the two chords meet, or the two line segments meet, well, they are chords, so we are going to use circle terminology. So the vertex is the place where the two chords meet. So that is an inscribed circle. So note takers, this is an NSCRIB, inscribed, INDLA. This okay, so, and then we're going to put it. Let me change this. I spell that right? Okay. And this too. All right, so now, oh, sorry about that. All right, so again, an inscribed angle has its vertex on the circle. Okay, so since it starts purple. Okay. So all right, so again, EPC is a straight angle, and it is also the diameter of the circle. FCE is an inscribed angle. Okay, you know, scribe means write. Write literally with your hand. So this is like an angle written inside of the circle. So FCE is an inscribed angle because its vertex, the point C, the place where the two chords meet, is actually on the circle. Okay, so now, and hopefully it'll make sense now. So APC, now those of you who I had last term, if FCE is an inscribed angle, what type of angle is APC? You remember the term?
Ain't that an obtuse central angle?
It's not obtuse, so take off obtuse and bring it back.
A central angle.
Yes. Why is it a central angle? What makes it a central angle?
Hold up. Let me get it my face straight before I get that.
Oh my.
Hold up. I better come back.
All right. Anybody from the class last term? You remember why that will be called a central angle? Or anybody who's here? A, let me show you again. A, it starts at A.
All right, before I died, it was a right.
So APC is a central angle.
Because all right, so A is a starting point, right?
A is where it starts. What happens at P? What is P to the angle? What part of the angle is P?
That's the vertex, right?
Exactly. So the vertex is P, and then from P, we end at the point C, which is on the circle. So why is it a central angle?
All right, now I don't know that part. I just knew that the part that I just is.
Well, what is center? What is center of the circle?
The middle.
What is the middle called in this circle? What's the name of the middle of the circle? Huh?
Which one, the diameter?
No, I said, what's the name of the middle of the circle? You see, you got everything got a name because it's a point. So what's the name of this circle? What is the center point? That's all I'm asking. What point is at the center of the circle? Somebody can help her.
The radius.
Wait a minute. The central angle is made up of two radii. Yes, it is. So the radius does play a part. All right, so the vertex, where's the vertex of the circle? I'm sorry, where's the vertex of the angle?
The vertex is you said from like I just said it, then I said from A to P. Yeah.
Yes. So what's the vertex?
A to P.
Not A to P, just P. The radius is A to P.
Right.
But the vertex is just P. Ladies and students. Because I have to look and see. Let me look at participants. Okay, so yeah, I'm gonna say ladies and gentlemen. Hey Faye, glad you're here, love.
I'm lost. Like, I don't know how to do this for free. Like, last time I was kind of confused.
All right, wait a minute. Let me see. Wait a minute. The vertex P is at the center. Oh, vertex P, wait a minute, is at the center. All right. So that's not a good color. I need to go a little darker than that. Okay, give me 1 second and I will. I'm gonna turn that bright. Okay. So now, when you name, let's take a step back and bring it forward. So when you name an angle, right? An angle has 3 points. The first point is where the angle starts. The second point is the vertex. And the third point is where the angle ends, right? So the first question was, name the angles that you see. So the first angle, EPC, started at E, P is the vertex, and C is where it ended. Well, That's a straight angle, right? So again, remember, geometry is the builder. So some of those concepts you studied before, they starting to come together now in circles. Okay, so a straight angle is 180 degrees. So here, the angle EPC is a straight angle, but as it relates to the circle, it is a diameter. EPC is the diameter of the circle, right?
So how is it the diameter if it's a straight angle?
Because one, by definition, a diameter goes from one side of the circle to the other through the center. So because it goes through the center, it splits the circle in half. So if the whole circle, you see what I'm saying? So if the whole circle is 360 and the diameter splits it in half because it goes from one side of the circle to the other through the middle, that is the key to what makes it a diameter, because it goes through the middle of the circle. So it essentially splits the circle in half. So thus, straight angle, semicircle, okay? So that was the first angle that was recognized. So the second angle that was recognized, again, first, where does it start? Where is the vertex and where does it end? It started at point F. The vertex is point C and it ended at point E. So now that would be described as an inscribed angle, written inside. It's the angle written inside of the circle. And the key to knowing that it is called inscribed is the vertex is on the circle. The vertex is this point right here. Okay, remember, the point you name in the middle is the vertex. That's the turning point, so to speak. Okay, so FCE is an inscribed angle because the vertex C is on the circle versus the next angle that was recognized. Starting at A, the vertex is P, and then we end at point C. So now that is a central angle. And it is a central angle because the vertex is at the center of the circle. The vertex is here, P. Well, central angle, vertex at the center of the circle. Okay, so that's the difference between an inscribed angle and a central angle. The inscribed, the vertex is on the circle. Central angle, the vertex is in the middle or in the center of the circle. Okay, make a little more sense? Maybe, sort of, kind of, something like it.
Yeah, it makes sense.
It makes sense now? Okay. So now, the next angle that was called out was angle DPB. But again, that is a straight angle. But instead of being horizontal, it is on a diagonal. Remember, a diameter, as long as it goes from one side of the circle to the other, it can be horizontal, vertical, or on a diagonal. So here, again, this is the diameter. This is okay. I'm going to say this Let me change this to in the center of the circle, the vertex. Let's see. All right. So I put that in for a little more clarity for the inscribe, for the person who is a screenshotter. I named the vertex, and again, it is on the circle. And then for the central angle, I stressed in the center of the circle. Okay. And so that, again, for P, because we have another angle, D, P, A. What kind of angle is that? Would you call it a straight angle? Would you call it an inscribed angle? Or would you call that angle a central angle? Because again, in a circle, there are more than one of all of these types. Or is it an angle at all? Okay, but again, let's start at D. The vertex is P. And we end at point A. No takers?
No, because I'm just now getting to know the rest of the circle.
Well, but
I'm trying to figure it out.
Okay, so here's my question. Is it a diameter? Because a straight angle would in essence be a diameter. It's going to go from one side of the circle to the other through the middle point, right? Through the center of the circle. So is it a straight angle? Because this is the conversation you can have with yourself. Is it a straight angle, right? Because again, straight angle, one side of the circle to the other through the middle. That's a yes or no. And you know, all right? Then the second question you ask yourself, because now you're checking to see if it's an inscribed angle. Is the vertex of the angle that you're looking at on the circle? Does it touch the edge of the circle? If the answer is yes, then it is an inscribed angle.
So it's an inscribed angle, right?
All right, so I don't know. Here we go. D, P, A. Is the vertex on the circle? The vertex, remember, is the middle, that middle point.
Yeah, the vertex is P.
The vertex is P. Is that touching the edge of the circle? Making it on the circle? If the vertex touches the circle, the vertex will be considered on the circle. So is the vertex on the circle? This is the vertex. Does it touch the edge of the circle? That's a
My
yes.
fault. I was getting on a bus, so I couldn't really see.
Oh.
What we was talking about?
I said for this angle we are discussing, DPA. Is the vertex P, does it touch the edge of the circle?
Yes.
P?
No, the vertex is the middle.
Right. Therefore, if the vertex is in the middle of the circle, it has to be a central angle. So DPA is a central angle.
True angle, yeah.
Yes. Okay. So
yes.
those are the three things you consider. All right. So DPA is a central angle. Okay, and again, remember, there can be more than one. So don't just think, if that's not the angle that you saw, that does not necessarily mean that you are incorrect. That just means that somebody else saw something that you didn't. That's all that means. Okay? You looked left, they looked right. All right, so now we've seen 1, 2, 3, 4, 5. So we have seen at least 5 angles inside of this circle. And again, remember, think about how you learn to name angles. Where does the angle start? The letter in the middle is the vertex. That's where the two meet. If it's an inscribed angle, the vertex is where the two chords meet. If it is a central angle, what are these? From A to P, from A to C, from P to B, from P to E, from P to D. They are the what? I taught you the plural because you already knew the singular. So what is this? From P to A is the what of the circle?
Central.
No, go to the basics. The distance from the center of the circle to any point on the edge of the circle is called the what? And they all the same length. I don't care how many of them there are. In this picture, we have 1, 2, 3, 4, 5. What are they? And we know they're all the same length.
From P to what? P to
From P to A. What is that? What is that called? From the center of the circle to the edge of the circle.
Is that a straight angle or no?
It's not a straight angle because it doesn't go all the way across. It only
Right.
go
So
half, it only go halfway.
So E to C is a straight angle.
Yes.
And A to P, I mean, yeah, A to P is a central angle.
APC is a central angle. You got to finish the angle. Where does it stop? From A to P to C, that's an angle because that's a right angle. Right? That's a 90-degree angle from A to P to C. Again, the distance or the measure. If I know that the measure from A to P is 8 centimeters, what's the measure from B to P? From P to B. If from P to A is 8 centimeters, what's the measure from P to B? Ladies and gentlemen.
You said from P to A, that's 8 centimeters.
And then I asked you, so if you know the distance from P to A, what's the distance from P to B? If this is 8, what's this?
I don't know.
Why? Go back to the basics of a circle. If E to C is the diameter, right? What's P to C. If the whole thing is the diameter, cut it off. Go from here, from the middle to the end. What's that called? The whole thing is the diameter, and then half of it is called the what?
The inscribed angle?
No angle. Isn't it a radius, y'all? Isn't that the radius? From the center of the circle to the edge? Ooh. All right, so you got to remember that, ladies and gentlemen. A central angle.
Where everybody
made
sleep?
up-
Because I'm the only one talking. Like, I'm trying
that's
to learn. Like,
I guess, I don't know. Maybe it's the weather. I don't know. But ladies and gents, remember, a central angle is made up of two radii. Remember, the distance from the center of the circle to any point on the edge is the same, going all the way around the circle. So if the distance from P to A is 8 centimeters, then the distance from P to B is 8 centimeters. The distance from P to C is 8 centimeters. The distance from P to D is 8 centimeters.
how though? Like, what? How?
Because they are all radii. They all start at the center and go to the edge of the circle. So again, remember the circle it's perfectly round. So regardless of where I hit the circle, if I start in the middle of the circle, it's going to be the same.
Okay. Oh,
Okay.
yeah.
So if P is the park, the walk from the park to Edna's house, to Daryl's house, to Angela's house, to Brenda's house, to Chucky's house is the same as long as we starting from the park, because the park is the center of our neighborhood. Okay?
Mhm.
So the center of our neighborhood is P. So regardless of where we walk in the same distance if we starting at the park, when we hit this edge. Now what changes is when we go other places. So now here we going from Frank's house to Charles' house. From Charles' house, we going back to Ed's house. Well, that's inscribed because we had to walk from one side of the circle all the way to the other side, not through the middle. We just took the shortcut. Okay? And then we came back to Ed's house. So that's inscribed because we had to stop at Chuck's, and Chuck lived on the edge of town. Makes sense if we walking? So if your walk takes you to the edge, it's inscribed. But if your walk take you only to the middle, it's a central angle. Make more sense?
Yeah, so from P to A, that's inscribed, or is it central?
P to A would be a part of a central angle.
So what's the other part?
I don't know what direction you going. If you go to the right, you going to stop at C. If you go to the left, you going to stop at E. If you slant up, you going to stop at B. And if you slant down, you going to stop at D. So it depends on what direction you go once you get to P. But all of them, because you stopped at P to figure out where you going next, all of them are central angles.
So that answered the question you was asking from P to A, right?
Yeah, so from P to A is the radius. And then you figure out where you going. You going up, you going right, you going down, or you going left. But regardless of which way you go, it is a central angle. So you can create one angle here. That's one angle. A to P, you can go this way. That's 2 angles. From A to P and you went down, that's 3 angles. From A to P and you go left, that's 4 angles that you can create just going from A to P. Okay? And they are all central angles because you made your turn at P. Make sense?
Yeah, I get it.
That's what makes it central, because you went to P and then you figured out which way you wanted to go. Okay, all right, so we running out of times. Out of time. Okay, so I have a question. No, I'm gonna leave it there because I don't want to make sure if you are a screenshotter, make sure you take a screenshot of this, because these are, wait, I'm gonna take these out. These are the 3 types of angles we're going to be talking about next week, because we're going to then add a discussion about the arcs. But I want to make sure that you all.
This what we're gonna be working on this Sunday, right?
Yep. Exactly. Okay, so those of you who are screenshotters, make sure you screenshot Control and the button above 6. For those of you who are writing your notes, again, I encourage you to use color if color helps you. You know, you can, if you can make the entire angle the same color, you know, on your, in your notes, that might make sense. You know, and again, do a sketch. Oh, you don't necessarily have to, oh gosh. You don't necessarily have to draw it to precision. You know, you can do a sketch. And you
Yes, I got it. So, Miss Hick, if
Yes.
it don't start in the central,
Mhm.
it ain't. They all not going to be the same.
No, if it doesn't turn at the central, because you go here and then you decide which way you turn it.
Mhm.
So if your turn doesn't happen at the center, so if P is not the middle letter of your angle, then it's not a central angle, because P is the center of the circle. Okay?
Yeah.
Okay, because you see for the inscribe, the letter in the middle is C. It's not P, so it can't be a central angle. But you see in the next one, APC, that's a central angle. P is in the middle. DPA, that's a central angle. P is in the middle. Okay? So if the center point is in the middle of your angle, it is a central angle. Okay. I got Fabe. And make sure I have you all. Okay, let me take roll real quick. Oh, hey, Miguel, what's going on? Good brother, glad you're here. Hey, Bree, how are you? All right, and I got everybody else. I'm glad you all are here. Let me pull this down. All right.